Well, welcome everybody to another fun and exciting MLOps Masterclass today. Today we're going to be doing experiment tracking right. The ideas today are going to help you take a look at our product called JFrog ML and how we're handling experiment tracking inside of JFrog ML. But let's first kick off some introductions. Guy, if you'd like to introduce yourself.
Hey, Bo. Hey, everybody. Good evening or good morning, depending where you are. My name is Guy. I lead the product at JFrog ML, previously Quark, an MLOps startup that JFrog acquired about 9 months ago. I've been in LLMs for a couple of years now, and I worked in several companies, big and small. And what we're doing now at JFrog ML is really kind of figuring out how we unify ML, AI, and everything we do at JFrog, unifying software and build processes. Bill?
So I'm Bill Manning. I've been with JFrog for over 8 years now. I have a weird experience with throughout my life of different technologies that I've done every time with all the various companies I've been part of. I've actually been one of the voices and one of the people working on a lot of the products we have here. I joined the JFrog ML team. I joined the JFrog ML team back actually this January, beginning of December, and I'm super excited to be here again. So just in case you're not aware, this is a series that Guy and I do every month. We've had some previous sessions starting in December, which was our quick introduction to JFrog ML and what we were hoping to accomplish for our launch this year. JFrog ML, just so everybody is aware, actually was started off as a partnership with a company called Quack, which Guy was one of the amazing people as part of the acquisition because we acquired them. And we turned this into JFrog ML, which we've launched this year. We followed this session up in January with the ideas of software supply chain and ML and all the importance of actually making sure that everything that you're using for your software supply chain, including machine learning, is covered. Everything from models to dependencies to you name it. It's a great session to go ahead and get exposure to all the amazing stuff we do. Just so you're aware, JFrog is a CNA, so we're not just a software security company. We are also a security authority. We followed that up actually with the ideas of uniting traditional dev and DevSecOps with the ideas of AI and ML. That was also another fun and exciting session where we talked about the various approaches to using the JFrog platform for your ML developments using traditional approaches. And then last thing we just did before this was the ideas of securing those open source models. So we have the securing AI ML development in the age of DeepSeek, and how you can utilize our products called curation and product. We also one called catalog, which actually will tell you whether or not you're ingesting anything potentially nefarious. Our product is more like a firewall, and also the ideas of continuous security through the entire development lifecycle. So, saying that, let's go dive into the fun and exciting world of experiment tracking. So today's agenda, we just did our little previous recap of all the things that we've done in the past couple of months. This will be an ongoing series towards the end of the year, so please stay tuned every month when we're doing it. It's usually the last week or second to last week. Actually, it's the second to last week of the month. Also, we're going to talk about what is experiment tracking itself, what are the issues, caveats, and what all the pieces that make it up. The importance of reproducibility is one of the things that we're actually helping companies with. And then the idea is that being able to use other tools, such you might be a company that is using a tool like MLflow or weights and biases or with these things, on how you don't have to abandon those in most cases, but you can use them as supplementals to what we're doing and use us as your core foundation like you would for your software development. Now you could do the same thing for machine learning. So the first thing that we're going to talk about is models. Guy, do you want to take this one or do you want me to do this?
Go ahead, Bill, and continue on.
Excellent. So we all know the ideas of models in companies. JFrog had this adage of the idea is that every company is a software company. You've also heard the idea that software is eating the world. Now we also realize that every company is an ML company. You'd be completely surprised, the gambit of companies that are leveraging machine learning these days to do things. I always use the example of a buddy of mine. His son got hired by a makeup company. He graduated with a degree in machine learning from Berkeley. And we're all like, that's very interesting. And the thing is, they have high economic value. They allow predictability. They allow companies to do their jobs more effectively, more efficiently, target new markets. It's really crucial in those decision-making powers, right? So being able to look at the data, it allows you to act and work within those confines to make sure that you're doing things a specific way, whether it's a business model, whether it's a production model, whatever it is. Being able to have that data allows you to make better decisions based on trims and accuracy and things like that. Also, too, now things have been so deeply integrated into enterprise organizations. Everything from the customer support sector, down to advertising, down to personalization. You name it, it's deeply integrated into the stuff based on data that's provided. Right? Basically, take all that data that companies have been accumulating over time, and now using something tangible with it. And the thing is that, like I said, it's amazing just the sheer volume of how the industry is growing and how rapidly it's adopting. In our last session, one of the things we talked about was Hugging Face. Hugging Face, the largest public source repository of models, with almost 2 million models in that repository, where only just a year ago it had 500,000. That's insane. The amount of growth that's happening even in the open source modeling space. So saying that, making sure that you're actually doing everything you're in your best to make sure it's safe, secure, and compliant is some of the stuff we described in the previous session. And now we're going to talk about experiment tracking. And the thing is that before we do that, you need to understand, some of the mentality here. We, as JFrog, before acquiring Quack, had already been kind of laying the groundwork, for ML. But we're actually, heavily invested since 2008 in the ideas of DevOps and DevSecOps. And you look at, the SDLC in, say, DevOps, and you look at it, you go, okay, this is great. You have all the steps, curate, build, all the usual things about the SDLC. And you have development ops people, you have security teams, and they come together and form DevSecOps. All of a sudden, now we have a second stream of MLOps. And a lot of companies were very perplexed at looking at this and thinking that it was a completely different set of criteria, which it is. But at the same time, there are a lot of similarities. There are a lot of ways to do this that you can still have a standard MLOps lifecycle while adopting an SDLC mentality. So when you look at the software supply chain behind it, like we look at the software supply chain, and there's tons of sessions on this, by the way. It has lots of components. You have to have a model repository. You have all the dependencies, Python or whatever you're using for your dependencies to build your models. You have to do fine tuning and infrastructure to support them. Yeah, you need also inference infrastructure to make sure that you can go ahead and work with these models in some way, real time, batch, whatever, all the components that make that inference infrastructure important. Also, two things like model monitoring for like drift analysis and things like that when you're deploying a model. And of course, a way to manage the life cycle. And when we manage the life cycle, this is where we're going to start getting into the ideas of experiment tracking. So when we look at this, we realize that all these key components and stuff, and the knowledge that we've gained from having almost 8,000 global corporations use the JFrog platform for their software development, that we needed to make it so that companies could easily adopt ML and do it in such a way that's powerful, safe, secure, and compliant. So let's go ahead. What is experiment tracking? So with experiment tracking, what we're going to talk about, of course, is the idea that it's looking at a version of an ML model and making sure that you keep meticulous records on everything about that model, every little core component. And the thing is, that includes any parameters you might have set, any metrics that you might have gathered from actually running the model, the versions of code that were used in the model itself, the data that's used for this, and then some way to do things such as, comparison between models to make sure that when you look at two different models, you can see whether or not there is some sort of differentiation between them and what you did. And then basically what it comes down to is just a way to look at the model, get the how, what, why, and how on how this is being affected. What are the efficiencies behind this model? Being able to collaborate, be able to refine it. And the biggest thing is too is I think, and I think it's overshadowed sometimes, is besides reproducibility, it's also the concepts of collaboration, right? If I test a model, I build a model, and I do that, and I want to have one of my teammates look at it, I need an easy way for them to go ahead and do the same thing. So this way, maybe I can do things like doing a peer review of my results. Why is experiment tracking important? And Guy, can jump in here when we're talking about this, because like the thing is that one of the key factors of him coming from Quack and the idea of why they built Quack, which became JFrog ML, is one of the major key components is reproducibility, right? Being able to go ahead and build a model over and over again to make sure that you have the same results, and that when you're looking at it, you can stop maybe errors or make sure that there wasn't some sort of condition that made it run improperly. Another cool thing that we provide in our platform with JFrog ML is also comparison, right? Being able to compare two models to see what code has changed, the conditions change, does a different model, different hyperparameters, whatever it is, whatever the differences that provided the differentiation between those models is a big thing. And a way to do it very easily is another key component behind this. Efficiency, right? This is another thing too, is that to make things more efficient, to make the workflow for any sort of ML development more efficient. We look at, I don't have the spaghetti sprawl of ML tools that I usually show as part of my discussion, but you look at it today, there's a lot of interoperability problems. There's a lot of issues between different types of tools, and sometimes externalized experiment tracking tools outside of the mainstay of the standard ML development, can slow down, can bog down that. So having a tool that allows you to do this, or have a tool that works into your ecosystem more effectively, can make you more efficient. And then lastly, like I said, collaboration. Big fan of collaboration. You look at, I come from the days of where, the hot topic was obviously with the gray on my face and my hair. When we went from single programming to, pair programming, two in one keyboard, two programmers, and the idea of being able to collaborate. Well, in this day and age of disparate, tribes of people building stuff, it's much harder to collaborate. So a nice, easy way to do that. And I'm not going to say vibe coding. That's a whole nother topic that I don't want to get into.
I just
But
want to add something, Bill, to this.
sure.
Just like let's add a fifth point or something kind of overarching our all conversation. Many times, if you look at ML and ML tools, they speak about research, about experimentation, about things you do at the lab. And I always say that end of the day, data science has the word science in it, and science by nature is experiment based because you need to try lots of stuff. However, one of the big differences that we look at is that it's not enough to have an experiment. It's not enough to stay at the lab. It's cool, but this is not where revenue comes from. Revenue comes from being in production, which means actually touching it by users, actually having it live, deployed, working with business applications, with real users. And this is where the real experiment takes place, because you take something you built and you put it out there in the world. Now, if you go back, and don't go back, but if you remember the slide that Bill shared about the whole SDLC or the development lifecycle, it starts at the lab where the experiment kind of, is born, but then the experiment also must move into reality to validate it. And this is where we kind of see it holistically. It's not just the experimentation phase, but rather how do you look at the experiment from the development, the research phases, all the way when you deploy it to production, and it's a life cycle, so it goes on and on.
Absolutely. And actually, I'm glad you said that, because that's actually part of it, right? We start off with data sourcing, we work our way into data labeling, we do some data versioning, and then the fun begins, right? This is when we start building our code, right? You start building a model, we start training it, we start evaluating the model, we look at the model architecture, we go through this iterative cycle, it outputs a model version, right? And this is one of the things we're going to talk about today. And then for model version, we can deploy the version of that model, and then we can monitor it. And then based on that, we could scale the hardware maybe that we need for, part of this model deployment, or we could take the information we've gathered and send it back. But the sweet spot we're going to talk about today is right here, right? The experimentation phase, making sure that we capture all the things that make up this version that we've deployed and be able to take that information and work with it. Guy, anything you want to add here? That's kind of, I think, where we were trying to get to on that, right?
No, this is exactly what I said. Remember that everything is a cycle, and the cycle can actually loop back to every part, because you might be needing to loop back to the data source, or just to the data versioning, or just to the model deployment, because maybe the deployment kind of template wasn't correct. So every part of it is something you also want to version by itself. How do you go back to the previous kind of day? What happened last week? Where were you at the previous state? Everything needs to be really tracked in order to kind of incorporate this flows into your production application. But I say, let's go on, Bill.
Sure. So what gets tracked, right? As part of this, this is one of the things we want to make sure that everybody understands, right? Parameters. First of all, high parameters that were used for this, right? Your learning rates, the number of layers, all the things that is entailed when working with a model. Also, too, the metrics, right? How did it perform as part of this? The accuracy, precision, recall, right? All the things that you do as a machine learning, expert when you're doing this. In addition, the data. Like, let's talk about the data that gets used for this. You can have your localized training data or the data that you're ingesting to actually use the model. Whether it's a real time or a batch or however you're doing this. Most of the time, what it comes down to is also to remember when you're looking at this, one of the things that we store as part of this, and we did this in the intro session, and we can show part of it as part of this today too, is that when we are doing a build, which was what you deploy into JFrog ML, you can also capture that training data. So once again, it's reproducible. So if I pull the model, I can go ahead and use the same training data to see if I get the same results. The code, right? The code that makes up the model itself is another key factor here. And we'll talk about that because besides the way, yes, you have it in some sort of version control, whether it's GitHub or whatever. But at the same time, if you have a nice place that's actually with the actual storage, and we'll actually talk about that today, how you can use JFrog Artifactory as a way with our machine learning repository to store that information. And then lastly, all the artifacts to come with it, right? Everything that was used for this. I mean, this comes down to all the dependencies that were used for it and whatnot, and we'll discuss that too. Anything you want to add, Guy?
No, I think that the only layer that you also want to have in mind, I think we talk about this also later on, is security. So
Yes.
security is kind of embedded throughout the process. And it's not just a buzzword, because remember that what you produce is actually a lot of files. Every experiment is a lot of new files that you introduce, whether it's code files, model artifacts. And we also kind of seamlessly integrate security, whether it's file scanning, whether it's malicious code detection. So we kind of integrate this in every step of the way and of the previous kind of step that Bill showed, because creating kind of correct ML experiments is exactly as important as making it secure and safe, both from your organizational policies and file security. So we also have this kind of angle in mind.
Absolutely. And if you want, guys, go back and go to our JFrog page and look at our webinars, our past webinars. And Guy and I did an amazing job last month describing the security aspects behind this. That if you want an in-depth discussion, look at that. Take a look at what we did last month. Next thing, common pitfalls that a lot of companies run into, right? So some companies do some things like manual logging, right? Those things can be a real pain, right? There's no way to really track it optimally. Things can get lost. We've seen this before with some companies. I talked to one recently. They store everything in Excel spreadsheets, and they have a lot of problems with versioning and tracking those compared to the actual physical models that they're using or models that are deployed, right? Another thing too is that a lot of the times people use local storage, or they'll maybe use an object store, or they'll use an NFS or whatever it is. And in that case, once again, you're running into the same caveats that we've actually discussed in previous sessions, which is a lot of the stuff gets lost. One of the things we always talk about is like 85 to 90% of models that are built never make it to production in most cases. And in a lot of cases, a lot of that actually is in a way kind of almost miscommunication based on where things are stored over time. Companies are still trying to figure this out, and actually, the JFrog platform solves a lot of these issues. Also, too, keeping the models and the actual code base separate. Yes, you definitely want to store your stuff in a source code. Absolutely. But once that's actually ingested, tested, and modeled, you want to actually make sure that you store that all together. Once again, this solves one of the problems that we've seen, which is reproducibility. And then the thing is that a lot of companies are trying to use Git for not just the code storage, but all the other pieces behind it, or some other version control system. And in most cases, that's really not a good way to do it because there's a lot of bloat. It doesn't really have a direct correlation to a tool that you can use to say, make it reproducible. There's a lot of issues there also. And Guy, anything you want to add, or we good?
Yeah, I think just about where does where do these experiments take place? Like many
Yeah.
times, data scientists do this either locally on their IDE, whether it's Visual Studio Code, PyCharm, any IDE they want, But more common than that, they do it on Jupyter notebooks, whether managed notebooks, whether local notebooks. And notebooks are this magic place where you can run Python code, but it's very easy to get lost there, where you train something and then you don't really find the model artifact or the last artifact, or the notebook kind of reset, and then you need kind of a persistent storage layer. We many times see data scientists take notebooks as their source of truth. But if you just kind of trust the notebook, it's very, very tricky because it's kind of a mix between local storage to separate model and code bases. And we also take this into consideration, and we'll share how we consider this later on. So just keep this in mind.
Excellent. And one of the things that we want to do is want to help companies with certain bad habits that we've seen, right? We usually see things like lack of reproducibility. This is something that we hear a lot of the times. Like I said, adoption is a new thing. A lot of companies are trying to learn. They've had a lot of time managing software, and now they're trying to figure out how to, manage things around ML. Also, too, in a lot of cases, there's, because of these bad practices, in some cases, there's unreliable metrics or models, right? The thing is that in some cases, these can actually cause more problems, and a lot of it could be from different factors that we discussed before this. Also, too, in a lot of cases, a lot of people are still doing some sort of manual process behind this, and the thing is that one of the things that we've done with our JFrog ML product is we want to make it as easy as possible for, say, data scientists to do the work they need to do, but do it in such a way that they're able to have it done easily, right? With simple deployments, simple testing, simple evaluation to make their jobs more effective. And the thing is that getting the results, in a lot of cases, are stored in various places, or they're stored in things that you wouldn't normally want to store this information on because it's harder to correlate. And the thing is that the last bit of this is that I want to talk about before we dive in a little bit more is, of course, artifacts. Right. One of the things that you want to make sure that you understand is that by harnessing all the artifacts that make up an experiment can help you solve some of these bad habits, some of these bad problems. Right. So first of all, being able to have some way to track things through a set of metadata that's queryable, that you can go ahead and do that, right? So the information about the description of the model, any metadata associated, so this way, down the road, you're not guessing when you're looking at this, at least something you want to do. Also, too, being able to store all the information around models and the parameters themselves, right? So this way, later on, if you need to go ahead and do this, and say you pull a model that you want to test that you built months ago, you have a baseline somewhere that you can look at the baseline on that and make sure that when you store it, you have the way to compare it. When I ran this 8 months ago, I got these results. Here they are right here. But I want to, if I ran it again and they're different, why are they different? Also, too, the data sets, making sure you store those so that if you want to make it reproducible, again, you have the ability to pull those down to make sure you're still getting the same correlated results as when you first initially ran it. And then, of course, all the code and dependencies. This is big. Yes, you can store your code in GitHub, but having it all associated into a singular platform is one of the key factors that we do. This is one of the key things that actually JFrog as a platform brings to the table. We've been doing this for software development since 2008. Those third-party transitive dependencies, the builds you create, all the things that we've built into the platform are now the things that need to be leveraged for stuff around ML also. So they're not disparate between software development and ML development. They're just slightly different. And then lastly, like I said, making sure that you have all the metrics and information around each model that you're testing, each version of those models that you're testing, so you can correlate them to previous models. You can correlate them to other to other ones too, current or past. Anything you want to add in there, Guy?
Yeah. We work with a lot of enterprise and large companies. And one of the things that large companies care about is, I'll say, the fancy word called regulation. And this is many times very vague, like what is regulation in AI? It changes every day. What is regulation in ML? But still, you care about this. And what do most regulators kind of ask for? They ask for visibility. They ask for tracking data, metadata about models. They ask you to, let's say, log everything you can in case it's needed. And this is one thing that we also care about, is how do we kind of wrap everything in a way that's digestible if you need to kind of prove kind of a receipt of the model. We'll share it later, but something like an SBOM called an ML bomb. That's kind of one single file that contains everything about your model. That's very easy to share in case you need to attach it to certain flows, to certain products, to certain releases. So we also have this part in mind.
Yes, the MLOps stuff is going to become more and more important every time, right? We did the same talk for software build materials. I was the software build of materials guy, and for years, and now I'm going to become the ML bomb guy, which is I'm fine with. But we're going to have lots of regulation behind it. So let's talk. Let's go ahead. So when we talk about experiment tracking, it's the same thing that's equal to model versioning in our product. We'll discuss that, and we'll actually show you guys what that looks like. So first of all, let's understand the stuff that we're taking care of as part of this. So first of all, with JFrog ML versions, and this is the versions of the model, first thing, we're going to be storing is the source code. When you create your model and you create a build, and you can take a look at our previous sessions, one of the things that we do is you upload your model into JFrog ML, and one of the things that we store as part of this is, of course, the source code that made up that model. And this will allow you to do things such as easy traceability, also being able to do easy comparisons, which we'll show as part of this. We're also going to be storing all the model code itself, the actual model. So we'll talk about that, whether it's a foundation model, a model you created yourself, any of the model data that's part of this. Also, too, all the third-party transitive dependencies that were utilized as part of this also. And then, of course, all the metric information that is in there. So when we look at this, and we'll talk about that in a minute, when we show this, and we'll show this after we talk to a couple more slides, but the idea is that we are capturing all the information that is part of this each version you're testing and building. So let's talk about this. Guy, would you like to talk about these next parts?
Yeah, I think that one thing that you have to take in mind is that one thing is having a model, which is basically a huge file full of weights, let's say, which is actually the output. But that's not enough to have this live in production. What does it mean? In case you want to deploy this, have this as an endpoint that can really run at scale, it needs to live in what we call a build. A build is basically a Docker image that has all the dependencies, all the requirements, everything ready for you so you can run this model. And this happens automatically. Bill will show this on the platform. But in order to have a build, you need to also have dependencies. What are dependencies? They are the Python packages that you want to install. So imagine that you did an experiment back at home. You have a model version that you uploaded. You upload additional model information. You uploaded the parameters. You also uploaded the dependencies. And now you want to convert it or to kind of create a build out of it. So we do this behind the scenes for you. We create and we build this Docker, we install dependencies, and everything is always stored in Artifactory. It's going to be stored in an ML repository. That's a unique repository in the Artifactory platform that is specially built for ML models. It's going to be also living in a Docker repository. That's kind of one of the native, I guess, most common repositories in Artifactory. And then I'll be picky again and say security, because everything is also going to be scanned. Because if I gave you a base image with vulnerabilities, that's not too helpful, because what we want to do is eliminate that and have that kind of seamless for you. And so this is repeatable because it's very easy to log new versions. Bill will show this in a second. It's basically one Python command that you upload new versions. It's another simple command to convert it to a Docker image or a build. And then you can deploy this very easily. And this whole cycle allows you to log everything from the model artifact to the model code to the data set that has to do with it. And everything is kind of working there for you, either in one click or in multiple configurations that you can do via code, depending on how you want to see this. I think
Excellent.
you can, yeah. And then it can also be more intricate. You can just upload the model artifact, something you trained maybe locally on a notebook, and you don't really care about the source code. You just want to have the model kind of logged as a persistent storage layer. But if you want, you can also upload the entire kind of inference code. You can have custom inference code. You can have custom customization to the endpoints, everything you want. Everything is very simple in Python, and everything is wrapped together in that model version or in that experiment that you track on the JFrog platform. And the goal is really being very easy to do, either from the CLI or from Python. And I think we can switch to the platform to show how it looks.
Yeah, and just really quick, just to talk about this. So, guys, just so you're aware, the stuff we're about to show, the version stuff, all the stuff that we're showing here, will be available very soon. This is kind of lining you up, but simply to go ahead and use the Frog ML commands to actually log a model, to do a version, to do an experiment. You just simply, you have a model ID, which is a model build, which you've done here, and you can take that version and turn it into an experiment, a version like this. Or if you want to create an experiment, you can actually go ahead and do this. So we'll talk about, this will all be available publicly soon. But as stated, let's go jump in. And what's great is that let me go log into the platform itself. I'll go log in right now. This is one of the instances that we have. And first of all, let's go ahead and take a look. So actually, if you look now, our JFrog ML is now in the UI itself. It is not a separate tab in this case, which I'm very excited. I know Guy is very excited too. And let's go ahead and click in there. So, what's nice is that when you're looking at this, you have a grand overview of all the things that we have here. And let's go just take a look, first of all, at models. So if you look here, you have model settings and model groups, and then you have the actual models themselves. In this case, I'm going to go look at the sentiment analysis one. And what's great is that immediately when you click on the model, you're presented with an environment which might be actually the currently deployed environment. And if you take a look here, which is really cool, which I really dig about this one I'm showing you right here, is the fact that with our platform, and you can see this in previous versions, and we'll talk about it here too, is the fact that this model I'm showing you right now is actually also in a shadow deployment between two versions that I'm actually currently running, and I'm splitting the traffic. So I can actually tell you rapidly, by the way, if I am testing a model in a production situation, or if I want to shadow a model, I can replace it. I can do advanced traffic splitting. These are all things that are really cool and available. Well, let's go ahead and look at the tab right here. And what we have here is the tab called versions. And this is what we were talking about. So first of all, when you get presented here, you can see that each one of these actually has a version number and the version name. And the version name in this case just happens to be the timestamp. This can be overridden as an actual value itself if you wanted to, but we store them by default as the actual, in this case, date, right? If there's no data provided, we actually store this as the date. Say when it's created, is there a model framework, and then some other stuff, like fine tuning, batch sizing, and some other parameters that we've actually gone ahead and used. If we go ahead and we click into one of these, I'll just show you. In here, first of all, you can see this is associated. This build happens to be broken for some reason. We'll figure that out. But we give you the information. Here's some basic model metadata, where actually this information is being stored. And we'll show you that in a minute because it's really cool. You can actually see here that it's, like I said, a Hugging Face framework, what version of the framework, it's a Python runtime, and what version of Python is running. Also some basic parameters, right? Some specifications behind it, batch sizing, fine tuning, any data that you want to store there. And of course, the evaluation metrics, if you look here. Another cool thing that we've included as part of this, if you take a look, first of all, here's the machine learning bill of materials. This is one of the things that Guy was discussing, and I'm super excited about. So if you take a look here, you have some base information about actually what was used to compose this version right here. We even have a model card that is associated to it also, which is fantastic. So you have all the model card data as part of this. And say I want to go ahead and utilize this version, right? I want to take this version and I want to put it into a live testing model. I want to be able to go in. Now, as a data scientist, I can go in here and figure out some way I can get my IT team involved or whatever. If you're using our product, this is one of the coolest things. I love this. And Guy, I get a little excited about this, but I think this is amazing. So as a data scientist, I don't need to know anything about the infrastructure. Only thing I need to know is I want to do it, I want to deploy it, I want to test it. So I can go right here and I click on here and it says build version. I can give the build a name. I could say, this is test build 011. I'm going to go ahead and I want to choose my infrastructure, right? I could do CPU or GPU based infrastructure for this testing. In this case, I'm just going to go ahead and just use, I'm going to use a tiny for this one. I don't want to spend a lot of money. I can make it also GPU compatible. How awesome is this? The portability aspect of making this GPU compatible. And I can add some other tags to be like, beta, I can say like, beta build, 011. And then if I want to build this version, I just hit build, and now it's going to go ahead and take this version and go ahead and successfully start building this model. If I go here, I can show you that it's actually going ahead and it's going to go ahead and provision this and set it up and actually go ahead and deploy it. I can go ahead and see what code I'm actually deploying as part of this also, as you can see here. I can go ahead and see what files are being deployed, which they haven't been deployed yet. This will be part of it when it gets done doing its build. We have a security aspect here. Now, the security aspect, just to let you know, one of the things is that we've embedded this into our security. And if I show you and I go in and say I look at a build, maybe that's been deployed as part of this. This is a previous version. I can go into security and show you the fact that I might have some potential vulnerabilities and some security issues around this. So this is one of the things we discussed previously. But let's go back in too, and let's go ahead and look at our model again, right, under versions. What's great is that also too, you can go ahead and say you've made some changes or whatever, and you want to go ahead and do this. You can quickly say rebuild this version. So I can take this version and rebuild it and maybe test it again. But the whole thing is that we've made this extremely easy and super simple. And now this is when it comes down to versions. But once a build has been happening, which if you take a look here, you can see I have some builds. Here's that build I was just doing, right? That's part of what I was taking a look before. I can select the build. I can actually go ahead, do some quick inference testing, maybe on some information on a live model. I might do here. We provide some other additional information too. You can go ahead and look at a version that's been deployed and then maybe a previous version. We have the ability to do a compare. What's great about a compare is we give you everything about the build and the status of that build and any tags. We tell you the parameters. We'll tell you if any metrics have changed. Let me get one that's actually a better build. Like I think that was a faulty build that I personally did, so you can blame the operator here. Well, let's compare it with, say, another deployed version. But this allows you to go in and compare everything down to code between the two versions. This is amazing, right? Being able to check and see how this is like, you can do it extremely rapidly. Anything you want to add in, Guy, before I go talk about how things are stored?
No, I think that we can kind of wrap up with how things are stored, and then I'll kind of jump in.
Perfect. So one of the things is that when you look here and you look at a build, you can see where it says go to artifact. So I'm just going to go to it manually so you can actually see, but you can actually go exactly where I'm going to show you. So the sentiment analysis engine, one of the things that we've done here is that if I type in NLP, you can see I've got one called NLP models. Now, in this case, this just happened to be the name of the project that I deployed that sentiment analysis with. And I can say, here's the versions of the models. Here's my sentiment analysis. Right? If I take a look here, here's the versions. Now remember, we stored versions by timestamp. So here's the timestamps. If I expand this out, you can see here's the code, the model, and the information. So first of all, let me show you this. I can click on the model manifest. I can click on properties, and I can see all the information about the characteristics of this model itself. All the information I did for inference testing, everything right here. I can show you, as part of this, here's the code. I can show you all the code that was actually part of the actual model itself when I deploy this, and I can show you the actual model itself. So we have everything stored here in Artifactory. This is now a reproducible element. Anything you want to add in there?
So I think that if we go back to versions, one of the things we allow you is this abstraction. You don't have to really dig in Artifactory and look where things are, but we give you kind of this simple interface to interact with versions, to build them, to upload them. Everything is kind of wrapped up behind the scenes, so you're not having to kind of dig through multiple places in Artifactory. Everything is version audited. You get all the goodies from Artifactory, whether it's duplication, federation, all that things. But we give you this kind of seamless, very simple interface for data scientists to work with these experiments and log everything.
Exactly. And that's the cool part is that everything is integrated, it's simple, it's easy to use, and it's robust. And the best part is, like I said, I love the idea of being able to actually take a version, do a couple of clicks, have it go ahead and do the build for me, and let it go deploy in the background while I get ready to do whatever I need to do. And then I have accountability behind everything I've done. It's awesome. And like I said, look at our previous versions of what we talked about so you can go ahead and look at all the amazing features, and now it's actually all integrated into our common user interface, which makes it just awesome. Um, and I think, if you have any questions or you have any comments, or if you'd like a regular demo, please reach out to your representative or send an inquiry in. We have plenty of information. Just go to our JFrog page and send in a query. Just go to jfrog.com. But is there anything else you'd like to add before we say, bon voyage,
So,
adieu?
so, so I just want to say that I know it's a bit cheesy, but this is just the beginning. What we're showing you now is actually the first innings and the first features that we, as a startup that quite quickly integrated into the JFrog platform, kind of start to deliver. And what we're building now, and we have kind of a full roadmap as the one leading the product. I totally say honestly, we have a full roadmap of a lot of features that will kind of natively integrate many data science and AI things into our factory. I just want to remind everybody that AI and ML have both the model that you create, the model that you consume open source, the model from external providers like GPTs that you deploy. And we're building a lot of things to do experiments with both these models you create, the models you take from Hugging Face, the model you kind of use externally. How do you really seamlessly kind of work with the workflows that you have, but integrate with the platform? So this is really kind of the how things start, and it will evolve in many cool ways, because we all know that there's not going to be any software in the future without AI. Like AI and ML are going to be integrated with everything. And we kind of have this in mind, thinking how we integrate these flows into everything we do and everything our customers do.
Excellent.
So yeah, everything I have to say.
Well, thank you so much, Guy, for that insight. Like I said, even though I work here, I still get excited every time I see new things come into the platform and being able to talk to our customer base and also inform people how we're doing things. Um, Thank you for your time, Guy, and thank you for everybody
Thank
who's
you.
joined us, whether you're watching us live now or watching it in the future. But thank you so much. Next, just be aware, keep an eye out for some various conferences. And like I said, we'll be doing a lot of talks soon. But please let us know feedbacks, comments, or whatnot. And we look forward to talking to you guys in the future. Have a wonderful day and be safe, everybody.
Bye bye.
Cheers.